हेलो फ्रेंड्स, वेलकम बैक टू माय यूट्यूब चैनल। फ्रेंड्स, आज हम MCQ ऑफ डिफरेंशियल कैलकुलस BSc फर्स्ट ईयर की जो बुक है उसके MCQ डिस्कस करने जा रहे हैं। फ्रेंड्स, हमने ये MCQ डिफरेंट टाइप्स ऑफ स्टेट यूनिवर्सिटी में पूछे जाने वाले MCQ और MSc मैथमेटिक्स का जो एंट्रेंस एग्जाम होता है उसको ध्यान में रखकर बनाए हैं, तो आप इन्हें अपनी प्रिपरेशन के लिए ले सकते हैं। तो स्टार्ट करते हैं। लिमिट एंड कंटिन्यूटी, इंपॉर्टेंट रिजल्ट्स ऑफ लिमिट्स। फर्स्ट, अबाउट ट्रिग्नोमेट्रिक लिमिट्स। फर्स्ट क्वेश्चन, फर्स्ट फार्मूला, लिमिट इफ लिमिट x टेंड्स टू 0 sin x अपॉन x इक्वल टू 1 और लिमिट x टेंड्स टू 0 x अपॉन sin x इक्वल टू 1. Second, if limit x tends to 0 tangent x upon x equal to 1 or limit x tends to 0 x upon tan x equal to 1, or we can write this and this as it is 1 upon limit x tends to 0 sin x upon x, this factor equal to 1, therefore 1 upon 1 equal to 1. That is similar to that. Question 3, limit x tends to 0 sin inverse x upon x equal to 1, and similarly like this. This is very important, usually asked. Limit x tends to a sin x minus a upon x minus a equal to 1, or and limit x tends to a tangent x minus a upon x minus a equal to 1. Exponential limits. If limit x tends to 0 e raised to power x minus 1 upon x equal to 1, limit e raised to power lambda times of x minus 1 upon x equal to lambda, where lambda is not equal to 0 and maybe any integer, any natural number, integers or irrational number. Question number, formula number 3, limit x tends to 0 e raised to power x minus 1 upon x equal to log to the base e a, where a is a constant. Logarithmic limits, constants. Logarithmic limits. Limit x tends to 0 log 1 plus x upon x equal to 1. Limit x tends to 0 log 1 minus x upon x equal to minus 1. Limit x tends to e exponential log x to the base e exponential equal to 1. Next formula है L'Hospital rule. If fx and gx are two functions of x such that limit x tends to a fx equal to limit x tends to a gx equal to 0, ये कंडीशन इसकी कंडीशन 1, कंडीशन 2, कंडीशन 3 एंड कंडीशन 4. कंडीशन 2, both are continuous at x equal to a, both are differentiable at x equal to a, and also if f dash x and g dash x, that is first derivative of fx and gx, are continuous at x equal to a, point x equal to a, then limit x tends to a fx upon gx equal to limit x tends to a first derivative of fx divided by first derivative of gx. This is very important property. Next, continuity of function at a point. A function is said to be continuous at any point x equal to a if left hand limit equal to right hand limit equal to the value of function at that point that is left hand limit equal to right hand limit equal to the value of the function at that point. Important results of continuity. If fx and gx are two continuous functions at x equal to a, then this is very important results. If fx and if fx and gx are two continuous functions at x equal to a, then their sum, their subtraction, their products are also continuous at x equal to a. Or the multiple of f, that is, if we multiply fx with a constant c, then this function will also continuous. If fx divided by gx, where fx and gx both are continuous, then their function, which is equal to fx divided by gx, is also continuous function. This is very important results. Next, but if fx, इसका अब हम इसका वाइस वर्सा डिस्कस करेंगे. बट इफ fx प्लस gx, fx डॉट gx, fx upon gx is continuous, it does not conclude that the function, individual function fx or gx both are continuous or continuous. It may be continuous or may not be continuous. This is also very important result. फ्रेंड्स, इधर से हम MCQ डिस्कस करेंगे 2-3 प्रॉपर्टीज के बाद. इफ fx इज ए कंटिन्यूस in its domain, then their modulus function, the modulus function of fx, is also continuous in the domain. If fx is continuous in its domain, then 1 upon fx is also continuous in its domain minus the point at which the value of function equal to 0, because at that point the value of this becomes infinite. The function not continuous at the function not exist at that point, that is point at which fx equal to 0. Property number 3, if fx is continuous and gx is continuous at x equal to a any point, then fx, which is equal to the product of fx and gx, not necessarily to be discontinuous. It may be discontinuous but not necessarily. Property number 4, if fx and gx both are discontinuous, then their product phi x not necessarily to discontinuous, that is, the function may be continuous or may be discontinuous. Product, this is very important property. Product of two continuous function may not be continuous function. फ्रेंड्स, अब हम MCQ कुछ 10 MCQ इसके बारे में डिस्कस करेंगे. क्वेश्चन नंबर 1, इफ fx इक्वल टू 5x minus 4 at x less than 2 and 2 into x square minus 1 at x equal to 2, then the question is, then find limit x tends to 2 fx is equal to. फ्रेंड, जो इसका सॉल्यूशन है, इफ दिया गया है, इफ लिमिट x टेंड्स टू fx इक्वल टू, हमें x इक्वल टू 2 पर निकालना है, तो x इक्वल टू 2 पर ये है, लिमिट x टेंड्स टू fx इक्वल टू लिमिट x टेंड्स टू 2x स्क्वायर माइनस 1, x पुट x इक्वल टू 2 का स्क्वायर 4 minus 1 3, 2 into 3 equal to 6. That is option B is the correct answer. Question number 2, the value of limit x tends to 0 to e raised to power minus 1 by x square is. फ्रेंड, इसका जो सॉल्यूशन है, लिमिट x टेंड्स टू 0 2 raised to power minus 1 upon x square, हम इसको लिख सकते हैं 1 upon 2 raised to power 1 upon x square, which if we put x equal to 0, then 1 upon 0 equal to infinity, that is 2 raised to power infinity, or 2 raised to power 1 upon 2 raised to power infinity equal to 0. That is option C is the correct answer. Question number 3, the value of limit theta tends to 0 1 minus cos theta upon theta times sine of theta is. Friends, we will do this problem by L'Hopital rule. Here if we put theta equal to 0, then 1 minus cos theta 1 minus, that is 1 minus cos theta 1 upon 0 into 0, that is 0 by 0 form. So we can do this by L hospital rule. So we will differentiate this function and this function, but before differentiating this function we can simply this, because we know that the standard result sin theta upon theta equal to 1. So we will multiply in denominator by theta. So we left here with 1 minus cos theta as it is upon theta square, because this factor equal to 1 minus cos theta. This is again 0 by 0 form. Now we will do this problem by L hospital rule, that is 1 minus cos theta differentiation 1 minus of 1 0 minus of minus sin theta, that is sin of theta 2 theta की differentiation 2 theta square की differentiation 2 theta, that is if we take 1 by 2 outside, then we left with sin theta upon theta, that is 1 by 2. That is option number D is the correct answer. Question number 4. If fx equal to mod x upon x, if x is not equal to 0, then the limit of f at x equal to 0, that is 0, otherwise b, if x is not equal to 0, that is x belongs to real number minus 0, because 0 पर function value mod x upon x है. Then the limit, then we will find here limit of f at x equal to 0. So friends, ये complete. Question number 4. हमें इधर लिमिट ऑफ f निकालनी है, तो इधर से स्टार्ट करते हैं पहले. We know that the mod function for x less than equal to 0, the value of mod x equal to minus x, and for the value of x greater than 0, the value of mod of x equal to x. Therefore mod x upon x for x less than 0 is, that is minus x upon x, which is equal to minus 1, and for x greater than equal to 0, mod x upon x equal to 1, because mod x equal to x upon x got 1. That is equation number 1. Equation number 2, left hand limit is not equal to right hand limit, therefore the limit of the function does not exist. That is option D is the correct answer. Question number 5. The value of limit x tends to 0, 1 minus cos x upon x square is. हमें इसकी लिमिट निकालनी है. अगर हम x डायरेक्ट पुट कर दे तो ये 0 by 0 फॉर्म बन रही है. सो by L hospital rule, these are also continuous and also differentiable and not equal to 0. But this is equal to 0 at x equal to 0 when we differentiate this. So we have to apply L hospital rule multiple times here. Question number 5. This is 0 by 0 form, and differentiation of 1 minus cos x sin x upon 2x. If we left with 1 by 2 outside, sin x upon x equal to 1, that is 1 by 2. Option B is the correct answer. The value of limit x tends to 0, 1 plus tan x upon 1 plus sin x whole raised to power cosecant x. हमें इसकी वैल्यू निकालनी है. So we can simplify this in this way. टेंजेंट x को लिखेंगे हम sin x upon cos x, एंड ये cosecant x से बाहर. cosecant x को लिखते हैं हम 1 upon sin x, और cos x हम मल्टीप्लाई करेंगे, cos x से डिवाइड करेंगे, and in the denominator 1 plus sin x cosecant x equal to 1 upon sin x. Now we know that limit x tends to 0, limit x tends to 0, either we limit x tends to 0, limit x tends to 0, 1 plus x whole raised to power 1 by x equal to e. Here 1 plus x upon इसका अपोजिट है, इनवर्स है इसका मतलब cos x अपॉन sin x, दैट इज 1 प्लस एक्स होल रेज़्ड टू पावर 1 बाई x, ये आउटसाइड है पहले, अपॉन 1 प्लस sin x divided by 1 by sin x, this is factor equal to e and this factor inner factor is also equal to e. So therefore we left here with e raised to power 1 upon cos x outside divided by e. If we put x equal to 0, 1 upon 1 raised to power e की power में 1 upon 1, so e upon e equal to 1. That is option B is the correct answer. Question number 7. The value of limit x tends to 0 sin hyperbolic x minus sin x upon x sin square x is. Again we will apply L'Hospital rule, that is this function is 0 by 0 form. So we first simplify this, that is we will multiply with x square sin x square upon x square, this factor equal to 1. Therefore this factor, remaining factor will be sin hyperbolic x minus sin x divided by x cube. So first differentiation, cos hyperbolic x minus cos x upon 3x square, this is again 0 by 0 form. So we will again apply L'Hospital rule, that is cos hyperbolic की differentiation sin hyperbolic x, cos x की differentiation minus sin x, that is minus plus sin hyperbolic x, 3x square का differentiation 6x, this is again 0 by 0 form. There again applying L'Hospital rule, sin differentiation cos, sin की cos 6x की 1, this it is 1.6. If we put x equal to 0, cos hyperbolic x at x equal to 0 equal to 1, again this is equal to 1, that is 1 upon plus 1 upon 6, that is 2 upon 6, 1 upon 3. That is option number C is the correct answer. Question number 8. The point of discontinuity of tan x r, the point of discontinuity of tan x r, the tangent x will be, the function fx equal to tangent x will be discontinued at x at any point if tangent x equal to infinite, that is function does not exist. Tan x, we know that tan x equal to sin x upon cos x, tan x equal to infinity means cos x equal to 0. Cos, we know that cos at 2n plus 1 pi by 2, where n belongs to integer, the value of cos x equal to infinity. So value of x equal to, value of cos x equal to 0, therefore tan x equal to infinity, that is function is discontinued. Therefore the tangent function x is, the function fx equal to tangent x is discontinuous at x equal to 2n plus 1 pi by 2. That is option C. A function fx is defined as follows: fx equal to 1 plus x upon 1 upon 5 naught 1 plus x at if x less than equal to 2 and 5 minus x if x greater than equal to 2. Then the function fx is option A, continuous at x equal to 0, continuous x equal to 2, continuous at x equal to 3, or all of the above. Here for x equal to 0 the function is this, and for x equal to 3 the function is this, that is x equal to 3, for x equal to 0. That is for left hand limit and right hand limit, the value of the function is same, therefore the function is continuous. And similarly for x equal to 3, at x equal to 2, 1 plus left hand limit 1 plus 2 equal to 3 and right hand limit equal to 5 minus 2, that is 3. Therefore option D, that is this is also this is continuous, this is continuous, this is also continuous, therefore ऑप्शन डी इज द करेक्ट आंसर. सो आज का हमारा लास्ट जो MCQ हुआ वो है, इफ fx इज कंटिन्यूस फंक्शन एंड gx इज discontinuous function, then their sum must be discontinuous function. That is, the sum of a continuous and discontinuous function is a discontinuous function. That is, it is a very very important property. This is all about for today. Thank you so much for